So this will be the last video for chapter 14a. So for this video, we're going to look at our second method to test the significance of the model, which means to measure the quality of the population model, trying to see if our sample model can be used to predicting the population. So last time we looked at the hypothesis testing. So this second method is called the confidence interval for the beta 1. Again, we are not looking for the confidence interval for B1 because B1 is the value we already estimated, so there is no uncertainty. So it is a value. So now we are estimating is the possible value for the population slope. So confidence interval for beta 1. So the reason we are learning this second method is because we are using this second method to test the significance of the beta. So to help you to understand how this significant value works, I want you to think about. So let's see. I have 95% confidence to believe beta 1 is between 0.2 and 0.3. So this is the first scenario. The second, I have 95% confidence to believe beta 1 is between -0.2 to 0.3. So look at the first case. So 95% confidence to believe beta 1 is between 0.2 and 0.3. Do you think, based on my 95% confidence, beta 1 can be 0? The answer is no, because my 95% confidence indicate beta 1, indicate that 0 is not included. So that means beta 1 cannot be equal to 0. However, for the second case, based on my 95% confidence, I believe beta 1 is between -0.2 to 0.3. So obviously 0 is inside this interval, which means 95 confidence indicate beta 1 actually can equal to 0. So that's the rationale of the confidence interval of the slope to testing if x and y have a significant relationship. So let's look at what we're going to do here. So we can use 95 confidence interval for beta 1 to test the hypothesis just as. So basically, the HO is rejected if 0 is not included in the confidence interval for beta 1, because I just show you if your confidence interval is not including 0, that means you don't believe beta 1 can be 0. So basically, you're going to reject beta 1 equal to 0. So for this confidence interval slope for beta 1, actually, you also don't need to calculate it if you have Excel. You will be able to find this interval directly from the Excel output. So let's go back to look at your handout again. So the same case. So look at these tables have the three tables. And so last time we are finding the p-values. So in this video, we are going to focusing on where to find the confidence interval for the slope. I'm going to minimize myself more because we need the edge of this table. So look at the third table. So look at the third table. So if you pay attention on the third table, you will see the last two columns, lower 95%, up 95%. So lower 95%, up 95%. And there is two rows. So this lower and upper 95% is the boundary of the slope of the betas. So which one is for beta 0, which one is for beta 1? Obviously, as we just learned where to find p-value, we understand all the value in the second row is related to the slope. So that's why, So that's why if you look at your regression output, and then the second row, there's two value, lower 95% and upper 95% will be the value for the confidence interval for slope. So now look at this case. So with 95% confidence, we believe the slope is between 14.6184 and 62.8932. So if that's the case, will we believe the x is significantly affect y? So first of all, in order to answer that question, you have to think, okay, if 0 included, obviously 0 is not inside this interval, so that means beta 1 will not equal to 0. So if beta 1 not equal to 0, that actually indicating x and y have a significant relationship. So in this specific case, x representing the year and y representing the share. So that means x, the number of the year work for the firm will significantly affect the number of the share the employee own. So basically, we will get the same conclusion as we did for the hypothesis testing, that the year and the share will have a significant relationship. So let's finish this part. So since 0 is not contained in this interval, the slope is significantly different from 0, so the linear relationship between year worked and the share required by the employee are significant, so which align with the hypothesis testing for slope. So basically, this is the second step, second method you can use to test the significance of the sample model, population model. So the conclusion from these two methods should be exactly the same. If the first model finds the hypothesis testing finds significant relationship, your confidence interval for the slope also should find a significant relationship. You won't be able to find different conclusion. If you do, that means somewhere you make mistakes. So the last thing I want to emphasize as we keep learning more and more relationship, so you have to understand when x and y has a significant relationship, it doesn't mean x cause y. In order to prove cause, actually involving a very strict scientific experimental design. Like I said, if you find the eating a bunch of cookie have a significant relationship with your gaining weight, you cannot say eating the cookie cause you gaining weight because you haven't able to control other factors. So maybe during that period of time, some people got pregnant, right? So then that might be the reason they gain weight instead of cookies. So that's why you cannot say x and y has a significant relationship means x cause y. That would be a very wrong conclusion. And also, if you won't be able to find significant relationship between x and y, you cannot say x and y has no relationship, because don't forget, we are assuming x and y has a linear relationship in this model. So if you cannot prove, if you cannot reject HO, that is indicating x and y has no significant linear relationship. You cannot say x and y has no relationship. So those are the two things I want to emphasize.